Next up is Anna Gerber from, or Anna Gerber maybe? Either one, apparently, from University of Sweden.
Thank you. So I'd like to talk a little bit about supporting scholarly annotation. So my background is as a software engineer at the University of Queensland, and for more than a decade we've been building software to support researchers around Australia, and a lot of those services include annotation services. So I'll just give you a few quick examples, because a lot of people think scholarly annotation means making notes on journal papers and that's about it, but of course it's much richer than that. A lot of the time annotation is used throughout the research process for collaboration, for training the next generation of researchers with interaction with students, for scholarly communication in those early phases, not just on the end results of the research. So we've got examples. This is an example annotating biodiversity records, so it was annotation of images, metadata, and maps. Annotation of 3D scans of museum artifacts, so in this case the annotation had to preserve things like the zoom level and the rotation, as well as annotating 3D regions of interest and annotating them with semantic tags. Annotation of protein crystallography models, so this was there was a standalone client for PyMol, but there was also a web-based client for JMol models, so it was annotating particular chains of those proteins or even particular individual parts of those models. Annotation of sensor data streams, so this was collecting data from sensors on crocodiles and other animals, and basically trying to identify patterns in the events to indicate the behaviour of those animals and to identify differences in those sensor data streams to reflect what the animals were doing. So the annotations were being generated by machine learning algorithms. Annotation of RDFA entities, so this was a bibliographic database, AustLit, which records information about Australian literature, and we had RDFA already in the page, so it's an example of inline annotation, but then we allowed users to annotate that RDFA with additional semantic attributes and entities in order to enrich that data. Annotation of textual variants within scholarly editions, so this is where you study lots of different versions of a literary work, and you compare in a very detailed way those versions to see how that text changed over time. And then just general kind of annotations of images and manuscripts and transcriptions, particularly in the context of scholarly editing, which is what I've been working on for the last few years, where you've got the ability to tag things, you've got the ability to have replies to annotations, so discussion that's going on. And a lot of these annotations are actually data themselves. So they're not just commentary that you sort of throw away when you publish an edition, but they actually become part of the published edition. So it's things like explanatory notes, historical notes, bibliographic references, and so forth. So out of all those different applications, and there are a number of others that I didn't show you, I've kind of identified some of the requirements of scholarly annotation and where they might be a little bit different than just web annotation in general. So one thing that's really important, because annotations become part of the scholarly discourse, we need to make sure that annotations have their own identity, that they are citable in the same way that journal papers are citable. And this means that they have to have identifiers, preferably persistent URIs, and this includes private annotations as well, because if you have access to the annotation, you need to be able to cite it regardless of whether your colleagues can actually see that annotation, so that they can know where to find access to that annotation. They need to be precise, so it's no good just annotating a web address. You need to be able to not only identify the exact region or the segment within a document or within a resource, but you also need to be able to identify perhaps the difference between semantic entities and documents. So, for example, I'm not annotating this web page about The Drover's Wife by Henry Lawson. I'm actually annotating the concept of The Drover's Wife as a work by Henry Lawson. Obviously, a lot of our use cases involve annotating segments or regions of resources. And this list of media types that we support for that needs to be extensible, because we're not just annotating text, PDF, HTML, images, video, audio, etc., but we're also annotating very specific research data formats, things like protein crystallography data models, 3D objects, research data that might be published through online portals like CCAN. So we need to be able to extend the list of media types that our model supports. And particularly one of the challenges we've had is where those those types appear within dynamic web applications. For example, annotating a map is a really common use case, but it's completely different if you're annotating through Google Maps versus a GeoServer map versus a leaflet application, etc. We need to be able to migrate or display annotations across different resources. So for a start, the same resource, just multiple copies. So if I've got exactly the same PDF stored on my personal web page as I've got in my institutional repository, I need to be able to move those annotations regardless of the fact they've got different URIs. Multiple representations of the same resource. So if I've got a TEI XML document that I've rendered using different style sheets into HTML, I should be able to display the annotations across those different representations. And particularly where we've got different actual file formats, so rendered to PDF versus HTML, and different resolutions. So a 3D model might be scaled down for web use, but the researchers are looking at a high-resolution version of that model. And then one that perhaps is more interesting for scholars is different versions of that resource. So particularly in literature where you've got a work that changes through the manuscript and the different editions of that work, you need to be able to annotate say the first version and have those annotations be able to potentially be displayed on future versions of that. And another example is where you've got something like the preprint version of a paper versus the actual publisher copy. So being able to migrate those annotations across. Typically we've used things like fuzzy annotation anchoring and storing bits of the content to do that, but then there are real concerns with copyright, because if you've got lots of different annotations and you're actually reproducing parts of the copyright, how do you make sure that you could keep control over that? How do you annotate non-information resources? For example, identifiers for conceptual entities or things that are in a database. For example, the representation of a manuscript that you know did exist but no longer exists, so you've got nothing digital to point at. Particularly important for literary scholars is the idea of standoff annotation. So Randall mentioned inline annotation. They don't like that because it modifies the original resource. You've got to maintain the integrity of that resource. A lot of our annotations involve multiple targets, so particularly where you're expressing relationships between different resources and being able to maintain ordering between those multiple targets. So for example, this version came before this other version of a work is a very common thing that our scholars want to do. And then also the idea of having multiple annotation bodies or structured content. So you've got things like multiple semantic tags and scholarly commentary contained within your annotation. Finally, some of the concerns from implementing these systems. So a lot of our systems have used the annotator model or the OA model more recently. So we've been able to generate, use a shared kind of generic backend, but then develop custom clients as browser plugins or as scripts or as bookmarklets. And having a standard model, like the OA model, has made this much easier, but in order to have seamless discovery and shareability, we need more than that. We need agreed protocols, we need standard APIs. And the flexibility of the model and of those protocols and APIs needs to be balanced against the ease of implementation. So the OA model is extremely flexible, but it is also extremely difficult to implement an annotation service that takes full advantage of the full range of selectors in that model because of the fact that the queries become very difficult to write. So that's all I really wanted to say. Thank you.
Paolo Ciccarese. Paolo. First of all, that was awesome because you really summarized all the problems that we can think of in our field. I have a lot of questions. I'll ask one. Do you have a feeling that a lot of those problems can be moved from the front end to the back end and have a good implementation of the backends with good protocols so that then we can use a lot of energy to understand how to relate to the users and make good products relying on a very scalable and powerful backend?
Yeah, definitely. A lot of those problems... so the question was, can those be moved to the back end so that we can then focus on making more usable clients? And I think yes. I mean, I have to admit my focus is always on back end development, so a lot of the problems that I was thinking through were back-end problems and problems with just the underlying models and the underlying protocols. I think we're never going to be able to have generic annotation clients. I think they're always going to have to be tailored for specific communities, and that's going to involve a lot of UX, UI kind of research, and they're completely different problems. That I think we really need to focus on those core model and interoperability questions.